Listen, just for a second. What do you hear? A low groan. The creak of stressed metal. The almost imperceptible sway of a giant lung inhaling and exhaling. The air is thick. It smells of resin from the plywood floor, a faint ghost of diesel, and something else, the salt of 1,000 oceans, condensed on the cold steel walls around you. It's dark in here. Completely, utterly dark. You are inside a box. And this box is flying. Suspended 50 feet in the air, held by a steel claw you cannot see, you are a single piece of a puzzle the size of a planet. A shudder runs through the floor. A sense of descending, of precise alignment with some invisible grid. And then a sound. A solid, mechanical click. That single, rotary certainty. That is the sound of the modern world locking into place. That one sound is why your phone, designed in California and assembled in China, is in your pocket. It's why the avocados from Mexico are in your grocery store in the dead of winter. It's why entire cities have risen from fishing villages while others, once mighty, have crumbled into rust. It's why millions of jobs have vanished and millions more, of a kind we could never have imagined, have been created. Someone somewhere had to invent that click. They had to decide the exact shape of the hole it fits into. And in making that decision, they accidentally drew a blueprint for the next 70 years of human history. This is the story of a box, a hole, and how they quietly ate the world. Our story, though, doesn't start on the sea. It starts on a clogged highway, in the cab of a truck, inside the mind of a man who is utterly, profoundly sick of waiting. His name was Malcolm McLean, and he wasn't a shipping magnate, not yet. He was a trucker from North Carolina. For years, he'd hauled tobacco and cotton, and at the end of every run, he'd sit in his cab for hours, sometimes days, just watching the excruciating ritual of the docks. To understand his frustration, you have to understand the world before the box. The world of break bulk cargo. Close your eyes and picture a 1950s New York pier. It's chaos made manifest. The air is a symphony of noise. The shriek of steam whistles, the rattle of winches, the bellowing of foremen, the clash of a dozen languages at once. The air smells of salt, creosote, fish, and the sour tang of the industrial harbor. A ship comes into port, and its belly is a chaotic treasure chest. It's a real-life game of Tetris, played in 3 dimensions by men with immense physical strength and nerves of steel. Inside the hold, you'd find an army of longshoremen. Bags of coffee from Brazil are wedged against crates of machinery from Germany. Bundles of timber from Canada are stacked beside barrels of wine from France. Each piece has to be handled individually. Men with hooks, nets, and slings would descend into the ship's guts, wrestling the cargo out piece by painful piece. It was an art form. These men knew how to balance a load on a sling, how to maneuver a crate through a narrow hatch, skills passed down through generations. But it was slow. It was dangerous, with a constant threat of a snapped cable or a dropped crate. And it was impossibly expensive. By some estimates, loading and unloading the ship could account for half, 50%, of the total cost of an ocean voyage. The ship, this multi-million-dollar asset, would spend more time sitting in port than it did sailing the ocean. And theft? It wasn't a risk, it was a line item on the budget. It was called pilferage, a gentle word for a constant drain. A few bags of coffee, a couple of bottles of whiskey, it was just the cost of doing business. McLean watched this slow, expensive, leaky dance day after day and thought like a trucker. He looked at his sealed trailer, loaded once at the factory, and then he looked at the chaos on the pier. The question that formed in his mind was so simple it was revolutionary. Why are we handling the cargo twice? My trailer is already a perfectly good box. We loaded it, we sealed it. Why are all these guys unloading my box just to reload everything, piece by piece, onto their big boat box? The thought obsessed him. What if the truck could just get on the ship? This simple question became an all-consuming fire. He wasn't a sea dog, he was an outsider. He saw the problem with fresh eyes, unburdened by centuries of maritime tradition. His obsession led him to make one of the riskiest bets in business history. He sold his trucking company, a large, successful enterprise, and poured every penny into buying a rusted, second-hand shipping line. The shipping old guard scoffed. A trucker from the sticks telling them how to run their business? They laughed him out of their offices. But McLean was relentless. On April 26, 1956, his grand experiment was ready. A refitted World War II oil tanker, the Ideal X, sat at the port of Newark, New Jersey. But instead of a deck full of pipes, it had a custom-built spar deck. And sitting on that deck were 58 gleaming aluminum truck trailers. Not the cargo from the trailers, the entire trailer box, lifted right off its wheels. Imagine the scene. Old-school longshoremen, hands in their pockets, watching with suspicion. Where was the army of workers? There were just a few men and the groan of a single crane. One by one, the boxes were lifted and bolted down. Where it used to cost the industry nearly $6 a ton to load cargo by hand, McLean's team did it for just 16 cents a ton. The ship was loaded in hours, not a week. As the Idealex sailed for Houston, a new age began. Not with a bang, but with the quiet hum of a diesel engine pushing a deck full of boxes out to sea. But this was only Act 1. There was a problem. A huge one. McLean's boxes worked on his trucks and his ships. But what about everyone else's ships? Or the trains? Or a port in Japan? The system was still just a collection of incompatible, proprietary parts. The true revolution wasn't just the box. It was making all the boxes everywhere speak the same universal language. And for that, we need to meet the quiet genius of the story. A man named Keith Tantlinger, an engineer working for one of McLean's competitors, Fruhauf Trailer Corporation. Tantlinger was tasked with designing a better box. He knew that the corners were the key. The corners were where everything happened. They were where the box was lifted, where it was stacked, where it was locked down to a truck, a train, or a ship. The corner was the interface point for the entire system. He developed a hollow, brutally strong steel corner casting. And, crucially, a simple, elegant locking mechanism he called the twistlock. An oval-headed pin that could be lowered into the hole in the corner, then rotated 90 degrees to lock it securely in place. It was simple, strong, absolutely brilliant. And here's where the story takes a turn that corporate history almost never does. McLean, the visionary, saw that his proprietary system, however good, would always be a niche. To conquer the world, the box had to be a platform, not a product. In a move of incredible foresight, his company released the patent for the twistlock corner casting design, royalty-free, to the entire industry. He was giving away his competitive advantage, betting that a universal standard would create a market so enormous that it would lift all boats, especially his. He was right, but making that standard a reality would be a war of its own. Now, imagine a sterile conference room somewhere in the late 1960s. The air is hazy with cigarette smoke. Engineers and bureaucrats from a dozen countries are gathered around a table. This is the ISO Technical Committee 104. Their job sounds unbelievably boring, to standardize the freight container. But they are, in fact, redesigning the planet's circulatory system. And they are fighting. This wasn't some friendly academic discussion. This was a commercial Cold War fought with slide rules and blueprints. The Americans, with their wide-open spaces and massive highway system, wanted bigger boxes, 24, even 35 feet long. The Europeans, with their older cities and smaller rail systems, fought for smaller, more manageable sizes. National pride was at stake. Competing patents were on the table. For years, they argued ferociously. Over lengths, 10 feet? 20? 30? 40? They argued over height. They argued over stacking strength. But most importantly, they argued over the final, exact dimensions and tolerances of Tantlinger's corner fittings. The precise shape of that keyhole-shaped aperture. The distance between the holes, down to the millimeter. They understood that what they were doing was defining the global handshake. This was the universal language that would allow a crane in Rotterdam to speak to a box made in Korea, destined for a train in Chicago, without a single moment of confusion. If they failed to agree, the entire dream would fragment into a dozen incompatible, competing systems, and the revolution would stall before it even began. Finally, by 1968, a fragile consensus was reached. The box would be 8 feet wide. It would come in standard lengths of 20 and 40 feet. The TU, the 20-foot equivalent unit, was born, and it would become the single most important unit of measurement in global commerce. And every single box, made by any company anywhere on Earth, would have those exact same corner castings in the exact same spots. They had standardized a whole. It sounds so small, but in doing so, they created a global agreement. They had invented a kind of trust forged in steel. And just as this new system was being born, it got a massive, brutal, and tragic accelerator: the Vietnam War. The US military had been toying with its own container system, but Vietnam presented a logistical nightmare of epic proportions. Ports like Da Nang and Cam Ranh Bay were insecure, unloading facilities were primitive, and supply lines were constantly under attack. Mountains of vital supplies, ammunition, medicine, food, would arrive and simply sit on the docks for weeks, rotting in the sun or being lost to theft. The new, standardized ISO container was the perfect solution. It was a secure, mobile, miniature warehouse. Suddenly, the US government became the single biggest customer for the fledgling container industry. Vast fleets of container ships were commissioned. The war became a massive, taxpayer-funded beta test for the entire system. It trained a generation of military logisticians who would later bring their expertise to the private sector. Crucially, it forced ports all across the Pacific, in Japan, the Philippines, South Korea, to rapidly upgrade their infrastructure to handle containers. The war was, in effect, building the tracks for the commercial boom that was about to come. The world was shrinking, and it was rearranging itself around the box. This wasn't a gentle process. It was a form of urban surgery, performed without anesthetic. Think of the old waterfronts, the finger piers of New York, the docklands of London, the viewport of Marseille. These weren't just industrial zones, they were the hearts of their cities. Crowded, chaotic, teeming with life, culture, and tens of thousands of well-paid, unionized jobs. They were surrounded by communities, bars, diners, apartments that served the men who worked the ships. But these ports were built for men, not for machines. The piers were too small for the massive new gantry cranes, the waters too shallow for bigger ships, and the historic streets behind them too narrow for the fleets of trucks now needed. They died. Not slowly, but almost overnight, they became obsolete. The entire economic heart of shipping was ripped out of the city and transplanted to vast, new, sterile terminals built on reclaimed swampland, places like Elizabeth, New Jersey, or the Port of Oakland in California. These weren't neighborhoods, they were machines. Fenced-off expanses of asphalt and concrete, patrolled by towering cranes that could load and unload a ship in hours with a tiny fraction of the workforce. Jobs that had supported families for generations evaporated. Union halls emptied. Bitter, violent strikes erupted but couldn't stop the march of the machines. The communities built around the docks withered. The box didn't just change shipping, it shattered a way of life. It drew a new economic map, and if your city, your neighborhood, or your job was on the wrong side of that line, you were simply left behind. But for those on the right side of that line, the box created a virtuous cycle of incredible power, a network effect. The more ports that could handle containers, the more companies built ships to carry them. The more ships, the cheaper it was to send a box across an ocean. And the cheaper it was to send a box, the more sense it made to manufacture your sneakers, your furniture, your electronics, halfway across the world. Suddenly, distance collapsed. It was no longer a physical barrier, just an accounting problem. Export zones exploded in places like Shenzhen, which went from a quiet fishing village to a sprawling megacity on the back of the box. Retail giants like Walmart perfected a new art form, just-in-time logistics. Why keep 1 million t-shirts in an expensive warehouse in America when you could treat the entire Pacific Ocean as your moving warehouse? Your inventory was now a series of dots on a GPS tracker, a spreadsheet of boxes scheduled to arrive just as the shelves were emptying. We built a global system of breathtaking scale and efficiency. Ships grew into metal leviathans, floating skyscrapers stacked with 20,000 boxes or more. The planet's commerce began to flow through a few key arteries, like the Suez and Panama Canals. It was a silent, invisible miracle of optimization. And then, in March of 2021, the miracle broke. The Ever Given, one of those new megaships, a quarter-mile long, got wedged sideways in the Suez Canal. For 6 days, one of the most critical arteries of world trade was completely blocked. A traffic jam of hundreds of ships built up on either side. Satellite photos showed this surreal image, a wall of boxes, a neon city aground in the desert. Each box was a promise. A promise of car parts for a factory in Germany, medical supplies for a hospital in Italy, semiconductors for a tech company in America. All of it stopped. Billions of dollars in trade, stalled per day. One stuck box wall revealed the hidden heartbeat of the system. And its terrifying fragility. This is the real pattern, the aha moment hiding inside the steel walls of the box. What the container truly standardized wasn't just a piece of equipment, it was a social contract. It's an agreement. We trade the messy, local, human-scale way of doing things for a rigid, global, brutally reliable system. That hole in the corner is a promise kept between strangers on opposite sides of the world. It is the USB port for the entire planet. Before USB, every device had its own crazy plug. It was chaos. After USB, you don't even think about it. You just plug it in. The container did that for every physical good. It replaced chaos at the edges with absolute certainty at the joints. And this system isn't just powered by efficiency. It's powered by emotion. The base emotion is a primal fear of loss. Fear of stolen cargo, of spoiled goods, of wasted time, of profit-killing delays. The box is a shield against that chaos. It's sealed, it's counted, it's insured, it's tracked. But the emotion it sells us, the consumer, is the hope for speed and order. The container didn't just move objects, it packaged time itself. Each TU is a block of the future that has been scheduled, bought, and sold. We, as a society, learn to think this way. In units. Delivery windows, inventory turns, productivity metrics. We have collectively outsourced patience. Which brings us to today. The fingerprints of that box are all over your life. Pull out your phone. That device isn't really a single object made in one place. It's a ghost, a specter, assembled from the journeys of a dozen different components in a dozen different boxes from a dozen different countries. The reason you can get fresh blueberries year-round, the reason a new television costs less than a plane ticket, is because of the shockingly, almost absurdly low cost of sending a container across an ocean. Our entire cultural expectation of 2-day shipping, of near-instant gratification, is a behavioral echo of the box's promise: frictionless arrival. We now track our pizza delivery with the same obsessive intensity that a logistics manager tracks a container ship. We view our digital calendars as manifests for our lives. The world has been rewired to the rhythm of the box. But the Ever Given and the massive port backlogs during the pandemic taught us a hard lesson. Hyper-efficiency creates hyper-brittleness. The system is designed to work perfectly with almost no slack. When it runs smoothly, it's invisible. The moment one part breaks, one canal blocked, one port congested, one pandemic, the whole global machine begins to seize up. The thin line between just in time and nothing at all is thinner than we ever imagined. And we have to acknowledge the environmental ledger. On a per item basis, container shipping is astonishingly carbon efficient. But its very cheapness is what enabled our disposable, hyper-consumerist, globalized world. It made it plausible to spread the externalities, the pollution from the factories, the carbon from the ship's smokestacks, across vast oceans and across time, far from the eyes of the consumer holding the final, shrink-wrapped product. So let's go back to where we started, to that dark space, to that one standardized, pitted, rust-streaked, perfect steel hole in the corner of a box. Within that simple geometry lies this entire, epic story. The story of a frustrated trucker's vision, of brilliant engineers fighting over millimeters, of the longshoreman whose world was rendered obsolete. It's the story of the silent, relentless logic that reshaped our cities, our expectations, our culture, and our planet. The past isn't behind us. It's locked in the corners of every box that passes by on a truck, a train, or a ship. And it's quietly waiting for the next click, the sound that says a piece of your world has arrived.